Good morning, everyone. My name is Wilhelmina Nekoto, and I am honored to be here today to deliver this invited talk on automated wildlife monitoring and poacher detection in Namibian Communal Conservancies. So I will just walk you through the points of discussion today, the Namibian HPC landscape, and then the motivation, define what communal conservancies really are, its economic and human impacts, the proposed solution of automating the wildlife tracking process, limitations of such a solution, and the possible other application areas. So the HPC ecosystem in Namibia is really young. It started in 2016, and it is about 3.5 years old up to present. And this is thanks to the African VLBI network project as part of the SKA, as mentioned by the previous speaker, Dr. Sitole, and the work of the Center for High Performance Computing in South Africa, who donated the first set of racks titled Ranger in 2016 and has been in operation since up until now, present. And then the second set of racks were delivered in last year and has also been in operation since. But we only have slightly more than 50 users and about 500 jobs. And the main objective for these clusters were to build capacity in HPC, human capacity in HPC, and also for computational research initiatives. So the ecosystem is quite small and also very young. But coming straight out of varsity, I wanted to do more in terms of leveraging such an ecosystem to address challenges faced in other economic sectors. So initially, when Marek asked me to deliver this invited talk, I was both very nervous and highly excited as well to talk about all the cool projects that and ideas that were underway within the key economic sectors for economic and human impact, starting with the mining industry, where I previously worked in just recently, in the design of digital twins for mineral exploration, which is a really big problem, and in waste management, and also in other sectors such as agriculture for disaster and risk management, because Namibia is a very dry country, and in tourism, which is very dear to heart, such as wildlife conservation, and also to identify how we can use automation to identify emerging markets or address other social sectors such as the humanities in the design of digital colonial museums. So 2 days ago, we celebrated our 30th anniversary as a country against the apartheid regime, and there is a lot of data that is out there and needs to be captured, processed, and used for edutainment purposes, and also perhaps recreate fashion of that time. So this is a really big project that's dear to heart, to have these digital colonial museums and how we can use such an automation process and a growing ecosystem to process that data. But if I had delivered all of this, it would have been information overload. So I decided to focus on one sector, and that is tourism, so that because it encapsulates all the other sectors mentioned here as well. So when you think of tourism in Namibia, a few things come to mind: dark skies for astronomy, the amazing landscape, as it's one of the only few places in the world, if not the only place in the world, where the desert and the ocean meet. And of course, the safari. Everyone wants to go on a safari if they think of Namibia or Africa as a whole. And about 75% of Southern Africa's richness is really, of 75% of Africa's wildlife richness is found in Namibia. So when you think of tourism, safari, landscape, dark skies, and food are some of the things that come to mind. But before I begin with that, I really want to define this term communal conservancies, as mentioned in the title of the talk. After independence in 1990, the Namibian government established the Communal Conservancies Act, also known as Article 95 of the Namibian Constitution. And what's different about the communal conservancies and communities are that communal conservancies are self-governing democratic entities run by their members with fixed boundaries. Now, these are an economic asset to the rural sector and people, and by using conservation for poverty elevation. And we've seen a huge growth in the number of communal conservancies. In 1998, when the first communal conservancies were gazetted, there were only 4. And in 2006, we've seen this number increase to 44. And as of last year, we had 84 communal conservancies. This is a really great initiative. And we've seen how this has been a great, has impacted economically and socially as well. And there are mainly 5 types of conservancies. There's affordable lodging, community forests, sales and crafts, traditional villages which focus on cultural heritage, and the most popular is safari and trophy hunting, which has been very, very instrumental in wildlife recovery. Between 1960 and 1995, just slightly after independence, there was a huge decline in populations of the rhino and the elephant and other species such as the zebra and the springbok. But through the Communal Conservancies Act, we've seen a huge increase in wildlife population, especially the rhino and the elephant, moving from critical numbers such as 25 to 50 to up to 100 to more than 150 elephants and rhinos. And this one critical species, the desert adapted elephants and rhino, are now the most in the world and Africa. So this really plays communal conservancies, and especially safari and trophy hunting has played a very instrumental role in wildlife recovery. However, this is still under threat, and this helped, although there are many challenges within communal conservancies, such as development and the threat of loss in wildlife, which is the biggest contributor to the tourism sector. We had 2 main objectives for this project. The first objective was to measure the efficiency of current systems and future automated systems. And the second was to quantify losses. On measuring efficiency, we wanted to see how it impacts socially, economically, and socioeconomically. And on a social level, this is really where this entire project idea started, because there are many challenges within communal conservancy, such as identifying safe walking routes, as nearly every week in Namibia, a woman or a child, a girl child, is kidnapped and raped, or kidnapped, raped, and killed. So there is a big problem in terms of properly documenting the current documenting and addressing this issue. And this very problem was the one that inspired this, one of the reasons that inspired this project idea, because 14 years ago, our family as well, my family, was greatly affected by this. We lost my grandmother, who was walking home, and it was during one of the worst floods in the country. And she went missing for a few days. She was killed and organ harvested. So since then, it has been a project to try and address this issue, as well as in urban development. How does such a project impact on an urban level? Also at a gross national happiness level, because economically we measure GDP, but on a social level, we really measure the happiness of the community or environment. Also, how efficient it is in terms of food security, because other types of conservancies focus on traditional, on agriculture and grazing traditional villages. Economically, how does it impact economic sectors such as tourism and agriculture? as well as in identifying emerging economies to also address the employment issue. On a socioeconomic level, which I would also title as other, there's a need for data to influence research, to drive informed policy and decision making. And there's also a need for data to improve education and training so that we can create innovations to address challenges both in the social and economic sectors. And as well as in terms of urban development, which impacts on a social level, there's a need to for infrastructure development, such as broadband connectivity, which is really poor, and energy. So existing systems miss a lot of gaps in terms of the social and economic, and there's a need for a much more bigger solution that might leverage off some very good computational infrastructure to help mitigate these challenges. Another objective of this was to quantify the losses. Now, beyond the social, beyond what has impacted me on a social level, economically, about 10 years after the first incident, I met this beautiful family of rhino, and I grew very fond of them. I'd visit them often, and in 2016, they were all poached. They were shot dead and poached, all within a period of 7 months. 7 months. And this was at a game reserve that was home to about 8 or 9 rhinos. So this was very devastating on me, especially the family in the background who I grew very fond of. It's a baby cub and its parents. And poaching is really one of the big issues. And between 2005 and 2017, nearly a rhino was poached every day. And this has been a big loss to conservancies and game reserves as well, and communities, and it has impacted tourism, especially on this game reserve, as seeing and interacting with the rhinos was one of the reasons why people visited this conservancy. But there was a need to quantify losses beyond poaching because the country's so spread out. There are many game reserves and conservancies out there, and we don't really know how many wildlife losses or megafauna losses, such as those of the elephants and the rhino, are lost to poaching. Another factor is drought. So drought pushes the megafauna out of in search of food, and this makes them vulnerable to poachers as well. So that sends them out, and then that also sends people out in search of grazing areas because half of Namibia's population, a total population of 2.5 million, relies on agriculture. So this habitat conversions also brings about conflict, human-wildlife conflict between the humans and the wildlife as they're in search of food. And this also contributes to other losses, to wildlife losses. But this is not really properly quantified because there aren't many measures in place to mitigate wildlife conflict or to predict drought. So it's automating such a process can help answer some of these problems. So shortly after the loss of these wildlife family, I embarked on a journey to create a possible solution, or this idea that exists today. And this really officially took form last year when I sat down and really started thinking about how we can address the poaching issue and the tracking issue, to also address other problems in country computationally, also to grow our ecosystem through industry and academic collaboration. So I broke down the approach to 2 levels, on a human level and a technical level. On a human level, a friend of mine, Ndako Njelwangi Pandulwa, hosted a art exhibition. It was titled On the Brink. And in this art exhibition, we wanted to create awareness, awareness amongst our people, and so that they understand the importance of wildlife in the environment, and also because we needed participation from locals to be stewards and advocates. So Ndakunjelwa used recycled tools, or your basic tools such as needles and thread and little Tipex and acrylic gels to really tell the story of the rhino and why it's on the brink and what's happening on ground. And this exhibition took place a month after I started this project. So it was really great to be part of this exhibition and use the proceeds from the sale of art to assist conservancies that were struggling with material and the tracking process. So this was the community solution. On a human level, it was art for conservation to help the tracking process, to tell the story, to gain advocates and stewards, and so forth. So the community approach or the human approach was one way to look at it. But coming from a technical background, I thought we needed something more technical, because if we're talking about automation, then we needed something that would need to consider a technical approach. So the approach proposed to improve on existing manual systems of tracking and also to measure, quantify the efficiency of our system and existing systems as well in quantifying the losses. In terms of technique and data, we wanted to contribute to existing technique challenges within the field and also transfer learning of such an approach to address other similar challenges within communities and communal conservancies. Motivating the need for infrastructure development within communal conservancies or rural areas at large was also another reason or motivation for such a technical approach to drive collaboration within industry and academia or industries as a whole that might impact on an economic and both social level. So given shortly after the loss of my dear wildlife friends, I embarked on a journey to understand what this manual tracking process was. And a typical case scenario are that depending on the income of different conservancies, because conservancies focus on different types. So those rich with wildlife usually have higher profits than the others. So the typical scenario where a car is, and if there is a car within that conservancy, the tracker would embark on a 4-hour drive with some basic technical instruments such as a GPS device, a watch, notebook or journal, and a pen. So he would go out, and if he spots a rhino, he would write down its coordinates. And another is that many rhinos found within conservancies are dehorned to protect them from poachers. So because their horns are made from keratin, the tracker would have to sketch with his pen and paper how the horns are growing back and probably also identify the rhino by its name or tag if it has one. So this is really fascinating. But so this booklet is sent to the head office. The head office then sends it's sent to the head office once a month, and at the head office this booklet is then decoded into and stored within a database by a clerk or the chief administrator. So this is very interesting because we're not sure if any advanced analytics or predictions take place within this data and how much data there is. Because if this process started in 1998 when the first conservancies were gazetted, then they're probably sitting on a few hundreds of gigabytes of data by now. But there isn't any advanced analytics taking place. What's also to note is that the game, whatever is decoded from these booklets or the history is not accessed by the tracker. But also what's interesting is that there could be a possible duplication of this notebooks or editings. So if I just point my cursor. So what could be is that there could be possible duplication here, because a tracker could go out with an additional booklet, duplicate the coordinates, and probably sell it for income. As we said, that depending on the type of conservancy, are not all focus on safari and trophy hunting. So therefore, incomes might not be high. So this could be a problem where they could duplicate this process and sell the intelligence. So this was a very sad reality, and I really wanted to do something about it. So after that, I needed to do some work. So landscape mapping was another, to explore what kind of, if we're trying to automate something, then we need to understand what our environment looks like. So I explored 65% of Namibia's landscape, and we have three main biotic zones: the woodlands, which are really important for wildlife migration and act as corridors for wildlife migration, as these are our wetlands, and the two arid zones, which are the Kalahari Desert and the Namib. Also, engaging the communities was important to understand their challenges and the limitations, and also their expectations, and identifying other economic activities as well, such as mining, agriculture, farming, and the humanities, because of their rich indigenous knowledge. Infrastructure, to understand what the infrastructure was like, was also important, and broadband, such as broadband connectivity and energy supply, and that is almost limited to non-existent. Strategic partnerships is key in realizing such a project or an approach, because I needed to engage the private sector in terms of private game reserves, non-governmental organizations, and the government at large as well, to see what acts or policies would hinder such solutions or innovations. Method evaluations as well. We didn't think of recreating the wheel, so we needed to see what systems already existed, and we found that the University of South California was doing great work in this very area with two systems developed, Pause and Spot as well, and emerging tools from such as the Intel Trail Guard, which just was released last year. Earth observation was very important as well to understand these habitat conversions. So we needed that to address that issue, and also in traditional the conservancies that focus on forest management. So GeoGlam is one open source open data repository, and they have a lot of data on there which we can use as part of the solution. So that all became very helpful in understanding the approach, the project context, so and who to include in building such a project. So and project solution, a technical solution. So we had some AI components that focus on computer vision, which is one, and some machine learning on structured data. And then we needed to have some big data architectures as well for processing pipelines, ecology and nature reserves, because we needed data sets for research and training and innovation within this area of discipline, and remote sensing or earth observation to improve the mapping and monitor weather patterns to predict wildlife migrations. So the project context really mainly falls within these four. There could be more, but this is still an ongoing project. And then we came up with a solution. This is something that really makes me happy because it's very colorful and it gives me hope that we'll end up in phase 2. But we broke it down into initially three phases. The first phase was the immediate step, where we needed to source and install instruments for data collection. We needed to collect data. So we're talking about smart cams, drones, earth observations, the list goes on. And then the second step was to detect and count these objects, wildlife and humans as well, in these conservancies or within the protected areas of the wildlife. So, and then the third one was to predict poaching and grazing areas. How are they moving? Where are they moving? When are they going to move? So that was really important. And in areas where we had security forces deployed or community members as trackers, we needed to randomly predict patrolling routes. As we said in the previous process, there could be possible duplication. So if the data here is duplicated and sold, then it's sort of easier for someone to know where the wildlife is moving to and in which direction to look. So the planning was very important in planning the patrolling routes for rangers. And then the other was re-identification of poacher and tracking, and then motion modeling, which is really a new interesting field within the computer vision space, which is to extract structure from motion, and to extract structure from motion of poacher or wildlife, and also action recognition. This is really important because poachers are, I mean, communal conservancies or we in general are up against $1 billion industry. So poachers are highly sophisticated and well funded. So new methods have been cyanide poisoning, where they poison water holes, and then when an elephant or wildlife or rhino or other megafauna goes to the water hole, then they would drink, and then later on in the evening they would get very woozy, and then die, and then making it easier for the poacher to extract the horns or ivory. This was a similar case where in 2017 about 100 hippos were found dead from poison. So it's really cruel what's happening. But with motion modeling, we're able to detect any anomalous behavior. If there's a person at a water hole, what are they doing there? A person in strange way of in which the elephant or the rhino would be walking. So we'd be able to pick this up and send help immediately. This was really because, and this was interesting because the nearest doctor, often from a typical game reserve, is about 3 to 6 hours drives away. So it helps in immediately recognizing any anomalous behavior and deploying help when it happens. So with phase one, there's a lot of processes going there in the data collection space. So this is where we need to develop streaming architectures, implement processes that would detect and count imagery as well, as I said, and then continuously test and see how it would go about. With that, we found that existing systems such as Pause and Spot from the University of South California already exist. So it would probably be best to not recreate this very stage, but rather integrate it. And then we'd only be focused on two phases. But I think step one is very critical. Sourcing the instruments and devices would be very helpful. But there were a lot of findings that we found that might not actually work all too well with our visual data collection plan. And that's because communal land size is quite sizable. So a typical square kilometer is about 189 football fields. And communal conservancies, as we find out here, are about 42% of Namibia's land coverage. So 42% of Namibia's land coverage is some sort of communal conservancy of some sort. But there were some concerns with if we had to focus on visual data, we'd have some problems, and that is in communal land size and how much data we'd be collecting a day. So to start with communal land size, if we had to think of how we would want to realize this visual solution, especially through smart cams and the process of motion modeling and detecting object just on phase one alone. If we're collecting visual data, we would have to think of instruments that would enable us to continuously monitor in near real time the size of 355 million football fields. Now, this is a large number. And how much data would we be collecting? So, if in the wetlands of the country we have constant migrations, or where we pick up some megaphone of some sort, then per camera in a day, we'd be sitting with over 6 million images just from one camera. So how many cameras would we need to just inspect a square kilometer of land, or 189 football fields? So one would definitely not work. So we have to think of how many cameras we need and how much data we are able to handle, and where we would store it. So we could store the metadata, but we also need the images for evaluation. Where would we store the images? How often would we write the data to somewhere, to our storage system? Because infrastructure is very limited. In terms of infrastructure, we have limited to no broadband connectivity in many of these conservancies. So writing the metadata might work on mobile data, but again, you might not even pick up. It's often that it's been hard to pick up signal in many of these conservancy areas. So technically as well, what instruments are we looking at? The Intel, through the collaboration with the Leonardo DiCaprio Foundation, came out with a TrailGuard AI smart cams last year. But and that's just one of the systems. And then we have drones, and then we also have satellite imagery. But if we're looking at these camera traps for visual data, near real-time on-ground visual data, then we'd have a problem in one of the main biotic zones, the Kalahari and the Namib Desert especially, because this is home to critically endangered desert-adapted elephants, rhinos, and lions. But there are no trees in the desert. So you'd probably have a pole like that standing in the desert, but how many poles? Because we need to see. And these are also where a lot of the poaching activity happens. So, and where they move then to the ocean during harsh droughts in search of water or hydration. So there aren't any trees in the desert. So how would we set up our smart cams? But in terms of data and technique, although this is a challenge, we would have good quality data in varying conditions beyond luminosity. We'd have data, because of the Namib biotic zone presents really great weather conditions, confusing weather conditions, such as wind, fog, mist, heat, and sometimes rain all in one day. So getting this data and seeing how these technical equipment perform there would really be interesting, because this can be, in terms of technique, in urban settings and urban surveillance, this might come in handy. Computationally intensive tasks would be substitution and inference, where we would act out scenarios to see, so that it's much easier to train our algorithms to detect anomalous behavior when we talk about motion modeling. So computationally inference would be a very intense task, and as well as 3D reconstruction. As we mentioned here, one way to automate this, another way is also to detect to identify the rhino by the way its horns grow back. So in terms of 3D reconstruction, this would also be a really critical task. And also reconstruction of landscapes before, especially within this biotic zone, is another one of interest, to see how the landscape has really changed over time, which could also be used in gamification and so forth. again, back to the biotic zones, this is really important because this is home to desert adapted elephants, rhinos, and lions. But if you don't believe me that we have lions and deserts in the field, I'd like to show you this video of this cute elephant who visited us in December during severe droughts and extreme hot weather conditions, just in search for some first splash. So cute. So we do have wildlife who are migrating in, yes, very, very, very cute. So we have a lot of wildlife migrating into, if we come back to this, this is really home for elephants and rhinos. So it finding ways to improve the tracking process within this very important region would really be great. So visual data really presents a huge challenge. We can't present anything on it because this is still very theoretical on the size, on the communal land size, and what technical equipment we need and how much data we would be collecting from this technical equipment. It does give us an idea on why we need to grow our ecosystem and why we need to automate and how we should automate, because we would be addressing other challenges within conservancies that might impact economically. So relevance to other applications, really, if we look at this, is that when we look at phase one, by developing all the project context, if we look at big data processing pipelines and remote sensing and earth observation, and as well as the AI components context of the project, it would come in very handy in terms of big data analytics in other industries as well, which are found within communal conservancies and very close to communal conservancies, such as logistics. The port of Walfish Bay in Namibia aims or will be the biggest port in Southern Africa. So there is a need to analyze. They're planning on having a lot of sensors and IoT devices. So having an infrastructure and ecosystem in place could really come in handy for them, and especially if it's in country. So this is another motivation for a shared cyber ecosystem within cyber infrastructure within the country, and also growing and expanding our HPC landscape within country to address some of the big data analytic challenges within the various sectors, such as logistics and manufacturing, because we have new processing and manufacturing plants opening up. So and factories for chemicals, and they need to be connected in some way to find faulties in different processes. So this is another motivation for that. But also when we look at sustainable tourism, because during this pandemic, one sort of wants to know, telcos have an idea in terms of sustainable tourism. We know if we want to monitor any threats, probably telcos will be able to monitor threats in terms of tourism. Where are most tourists going to? Where are they not really tracking them? But if we find that a high number concentrated in very anomalous places, this could be one way in which telcos can really use information in a good way, maybe, or maybe not, hopefully in a good way. Urban safety is another. We see that crime in Namibia is very high, and challenges, crime in urban and rural settings are very high. So some components of such a system, especially phase two of such a system, and basically phase one as well, would be able to be used in designing affordable burglar systems, and also in traffic flow, we have some of the highest numbers of car accidents in the world, very alarming. So if we're able to see what happens on these highways when trucks from the port of Walfish Bay moving into other countries towards borders of Angola, Mozambique, Angola, Zambia, Zimbabwe, and Botswana, and the traffic times and the flow, we're able to understand what really causes this high number and alarming rates of road accidents. So this is another way in which we can use visual data to in an urban setting, as well as in smart farming and agriculture. I've had many farmers who really want to, you know, not track their wildlife on this large amount of land, not wildlife, but domestic animals such as their cattle for farming, and other, and sheep and goat. So they really want to monitor, to use visual data to be able to see how they're moving and to plan for drought disasters such as drought, in terms of seeking grazing areas and whatnot. And improve mapping in general. Road asset management is one. We can use such visual techniques to improve road asset management within urban settings, and also asset management in general in rural and informal settlements, because rural and informal settlements are generally underdeveloped, and we have more than a third of the urban population living in in urban settings, living in informal settlements. So many of the services, such as drainage systems or even water or ablution blocks, are non-existent. So it helps give some visual understanding, or immediate counting, and much easier counting to understand what is there and not, so that we can improve urban development. An interesting case actually came up last year as well during this process, was monitoring zebra snake patterns. So this is a very big concern now, also growing in urban settings, because these are highly poisonous snakes, and they're moving around, and there's no cure. So a lot of people are affected. But if they are geotagged, then it's easier to see, to analyze their movement patterns, also alert people when one is within range, and then it can be rehabilitated back within its ecosystem. But this has really become something of interest on how to use analytics and some machine learning to monitor and predict their patterns, and also do stuff with their. We're not able to get visual data, but if they have some geo data, then we're able to analyze that. So I'd really like to thank you for the organizers for this opportunity, and also to the a number of partners, the Computer Vision and Global Challenges community, who've really helped push this project, and the Game Reserves, the Deep Learning Indaba community at large, Mapillary, which has also been very helpful, and the EVS mining and contractors in Namibia, who've been my great help within the mining sector, and data science retreats in general. So this is work that's still ongoing, and it's only a year old. So I'd also like to really thank the people who are very instrumental in pushing me to start this, such as Mr. Nasangula, who told me to look at wildlife and apply my technical background to address, or look at wildlife and address problems that are faced in there. And my mentors and advisors, such as Tati Sam from the Ministry of Tourism, and Sarah Kendry from the Earth Observation, European Earth, European Space Agency. So that's really great, and everyone else who's really been instrumental in this journey. Please feel free to reach out and let me know how I can grow this and really realize it. And if you'd like to collaborate, or know someone from Intel who's willing to sponsor some smart cams, that would really be helpful. But thank you.
Thank you very much, Wilhelmina. That was really, really important work. It is very important work that you are describing. It's amazing that you have so much initiative and bright thoughts. Really amazing. So we welcome our audience to ask questions. Okay, we have the first question.
Okay. This is a very interesting question. We have not collected data yet. We are still at the stage where we would. Yes, I understand. We are still at the stage where we are designing our experiment, but if we were to collect data for at least a quarter of a year or even in a season, let's put it that, then I think doing it once in one particular region would be efficient. But this is still an area we're trying to explore. And also because there's very limited data on this, so I'm thinking it would be from scratch in some areas such as the desert biome, especially due to the extreme weather conditions. Yes, Ignacia, we do. Yes, we do.
So I
And
hope
also
that
because this is very important to us, as the Africa Millimeter Telescope is also coming to Namibia. So identifying projects of social impact economically is also important to that project, because with that would come increased cyber infrastructure, better connectivity than what we have at HES at the moment. And with this would also be, with the downtime, we'd be able to do some weather mapping, which would be much easier at very sub-millimeter levels. I hope that made sense. Yeah.
yes. So I hope that participants who have further questions, please
Thank you,
contact
Mark.
our
Thank
speaker
you.
after the talk. Thank you very much, Wilhelmina. That was really, I'm so happy that you could join our conference.